When a passenger jet touches down at over 150 miles per hour, one of the most intense moments of the entire flight begins. In just a few seconds, a machine weighing hundreds of tons must go from highway braking speed to a complete stop. Most people think pilots simply hit the brakes, but that's only part of the story. In reality, stopping an airliner is one of the most impressive engineering achievements in modern transportation. Imagine a Boeing 777 racing down the runway faster than many sports cars. Now imagine bringing that giant machine to a safe stop in a surprisingly short distance, without skidding, losing control, or destroying its tires. So how is it done? The first line of defense is the wheel brakes. Yes, airplanes have brakes mounted directly inside the landing gear. But unlike car brakes, these systems are built to handle extreme forces. During a heavy landing, brake temperatures can exceed 1,800 degrees Fahrenheit, 1,000 degrees Celsius. That's hot enough to seriously damage ordinary metal. To survive these conditions, modern airliners use powerful multi-disc carbon brakes. They're lighter, stronger, and far more heat-resistant than traditional steel brakes. But even these advanced brakes can't do the job alone. The real magic begins the moment the wheels touch the runway. If you've ever sat near an engine during landing, you may have noticed something strange. Just after touchdown, the engines suddenly get louder. It sounds like the aircraft is accelerating again. But the opposite is happening. The engines are activating thrust reversers. Instead of pushing air backward to move the aircraft forward, special panels redirect the airflow to create a force that helps slow the airplane down. For a few critical seconds, the engines are literally working against the aircraft's motion. It's like a giant invisible hand, grabbing the jet and pulling it backward. But thrust reversers aren't used for long. Once the aircraft slows enough, pilots reduce reverse thrust and rely on the next system. Spoilers. These panels rise from the top of the wings immediately after touchdown. Their job is simple but crucial. Destroy lift. Even after landing, the wings still want to fly. Spoilers force the aircraft's full weight onto the landing gear, allowing the brakes to work at maximum effectiveness. They also create additional aerodynamic drag, helping slow the aircraft even faster. Without spoilers, a jet could continue floating above the runway, dramatically increasing stopping distance. Together, wheel brakes, thrust reversers, and spoilers form a perfectly coordinated system. While passengers feel only a gentle deceleration, hundreds of components are working together beneath them. Every sensor, hydraulic actuator, and computer system must perform flawlessly. But what happens if something goes wrong? What if the brakes fail? Or the thrust reversers don't deploy? Aircraft are designed with multiple backup layers. Many airports use EMAS systems, special engineered materials placed at the end of runways. If an aircraft overruns the runway, these crushable surfaces absorb enormous amounts of energy and safely slow the aircraft down. Pilots also gain help from something completely natural: the wind. Commercial aircraft almost always land into a headwind. Why? Because a headwind reduces ground speed while maintaining lift. The stronger the headwind, the shorter the landing roll. In some conditions, landing with a tailwind could increase stopping distance by nearly double. That's why runways around the world are aligned with prevailing wind directions whenever possible. And sometimes pilots must perform incredible landings in challenging conditions. One famous example occurred in Düsseldorf, Germany, when an Emirates Airbus A380 battled powerful crosswinds during a storm. The aircraft approached the runway at a dramatic angle, appearing almost sideways as pilots fought the wind. Yet, thanks to advanced flight controls, spoilers, brakes, and thrust reversers, the giant airliner landed safely. The footage quickly went viral and showed just how much precision modern aviation requires. And if you think that's impressive, consider aircraft carriers. Naval fighter jets can go from around 150 miles per hour to 0 in just 2 seconds. Instead of relying on long runways, they hook onto arresting cables stretched across the deck. Miss by a fraction of a second, and the consequences can be severe. That's why aviation remains one of humanity's greatest engineering achievements. The next time you land and feel that familiar jolt as the wheels hit the runway, remember, stopping the airplane may be just as impressive as flying it. Because behind that smooth landing is a perfectly synchronized combination of physics, engineering, and pilot skill, all working together in a matter of seconds.